We start out Unit 2 in Chapter 3, Section 1, talking about graphing quadratic functions. Because of this, a lot of what we're going to go over in this video is going to be review for you, which is never a bad thing. A quadratic function, remember, is a second-degree polynomial, so the highest exponent is 2, and the graph of this function is shaped like a parabola. We're familiar with that standard graphing form where we have our transformations. Our horizontal shift is h and our vertical shift is k, so that we know the location of the vertex has shifted away from the origin to the values of h and k. For example, if this is the function I'm given, the quadratic function that I'm given and asked to graph, I see my horizontal and my vertical shifts. So the vertex is going to fall at 3, 8. This is a shift to the right 3 because the graphing form, that standard graphing form, starts as x minus h. So I have x minus 3, which means I have plugged in a positive 3 and it's going to move to the right. K is just plus k. It goes the direction we expect it to go. So I've gone to the right 3, up 8. That means that my vertex is centered there, that my parabola is centered there. So the axis of symmetry, the line where I could fold the parabola in half, has moved away from the y-axis. And it's that value x equals 3. So that if I took my parabola that has been shifted over to the left 3, and up 8. If I want to fold that parabola in half, I would fold it along this vertical line, and the value, the equation of that vertical line, is linked to that horizontal shift. Notice that the axis of symmetry is always given as an equation because it is a line. So it should always be x equals. Here we go, axis of symmetry, always the vertical line through the x-coordinate of the vertex, so the equation of that axis of symmetry is x equals h. Now, maximum versus minimum. This is determined by the highest or lowest function value, k, and that occurs at the vertex. So for this function that we have been given, this function f of x, right there, has a maximum, or excuse me, has a minimum because it is a positive x squared term. It opens upward, so it reaches a lowest point or a minimum point. And that minimum value is 8. It occurs at x equals 3. Where x is 3, the function value is 8, and that is the lowest possible function value, the lowest possible y value. My general form of the function, remember, starts out as f of x equals ax squared plus bx plus c. Now, if I'm given that general form, it does not show me where the vertex is. It's not my graphing form. So I have to do a little bit of work. Remember, hopefully, our quadratic formula where we had x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And we talked about the fact that this value underneath the radical is my radicand, it's my discriminant. It tells me how many and what type of solution I have. And I told you then that this piece gave us something else. This piece, negative b over 2a, gives me the horizontal shift of my vertex, the location of the vertex, when I'm in general form. Once I know this x value, I find the y value by plugging that into my function. So f at negative b over 2a is the vertical shift or the y value of the location of the vertex. Let's figure it out. Let's do an example. G of x is in general form, ax squared plus bx plus c. We want to know where the vertex is, and since it's not given to me in my graphing form, I don't know my transformations. What I know right now is that it's quadratic because it's a squared term, it's a squared equation, a squared function, second degree. That means that my graph will be shaped like a parabola. And I know that it will open upside down like this, which means I have a maximum function value. And I know it opens upside down like that because of that negative out front. That's one of my rigid transformations. That's a reflection across the x-axis. It turns my parabola upside down. These are the things I know immediately just by looking at this graph. I also know that if x is 0, my graph is going to be, the value, function value is 1. So that's my y-intercept. But I don't know the location of the vertex for this parabola. To figure out the location for the vertex, I find my x value for the vertex by using negative b over 2a from the quadratic formula. So I've got a is negative 1, b is negative 2, and c is 1. Negative b, or the opposite of b in this case, is going to be a positive 2 over 2 times a, where a is negative 1. That's the coefficient on this squared term. So I have 2 as my numerator and a negative 2 as my denominator. Anything over itself is 1. This is a positive divided by negative, so it is a negative 1. So we've started figuring out our vertex. Our vertex has an x-coordinate of negative 1. What about the y-coordinate? What about that vertical shift? Well, we take this negative 1 and we plug it into our function to find k, our vertical shift. All right, my function is minus x squared, so negative 1 squared, minus 2 times negative 1 plus 1. Be careful with those negatives. My first term, negative 1 squared, is 1 times a negative, so this is still negative 1. Negative 1 times, or negative 2 times negative 1 gives me a positive 2, and then I have plus 1. So this simplifies to 2, and that's the y-coordinate of my vertex. There's the vertex of my function. Let's go ahead and sketch this function. Okay, we've got a vertex at negative 1, 2. So negative 1 is to the left, 2 is up. And we know our function is going to open down. Remember I said that my y-intercept, which happens always where x is 0. If x is 0 here, y is a 1. So my y-intercept is 0, 1. So there is another point. I'm not going to take the time right now to calculate our x-intercepts, but I see that I have 2 x-intercepts. One is going to be a negative value, and one's going to be a positive value based on where the vertex is and where that y-intercept is. How did I know for sure that it opens downward? That negative out front. It's confirmed by the location of the vertex in relation to the y-intercept. The other thing that we've talked about on this page, maximum axis of symmetry. I see that if I want to fold, oh dear, freehanding graphs, never a good thing. If I want to fold my graph down the middle so that the sides match up, my axis of symmetry is going to be the line x equals negative 1. That is always going to correspond to that x coordinate for my vertex. I have a maximum value for this graph. I have a high point, it's a hill. And the maximum value of the function is 2. That's the y-coordinate of my vertex. It occurs at that axis of symmetry, at that x-coordinate. All right, let's look at the next page. Again, most of this is review. We've learned maybe a couple of new things so far today, and we're going to continue with some practice problems. All right, for the given equations, find each piece of information and then graph. We have f of x equals x minus 4 quantity squared minus 1. Well, first we need to identify which form we are in. Are we in that general form, or are we in our graphing or standard form? And we are in our graphing or standard form. I've always called this the graphing form. This book calls it the standard form, so I'll throw them both out there. When we're in that form, we are given the vertex. We have our horizontal and our vertical shifts. So I know that my vertex is at 4, -1. I move over to the right 4, 1, 2, 3, 4, and down 1. There's the vertex of my graph. Now my graph opens upward, so I will have X-intercepts. Let's go in order though. Axis of symmetry corresponds to the x-coordinate of my vertex, always given as an equation x equals. So in this case, my axis of symmetry is x equals 4. We know because our x squared term is positive that our parabola will open upward, which means we have a minimum value. And the value at that minimum is the y-coordinate of our vertex, -1. Our x-intercept happens when, our y-intercept happens when x is 0. We will never have more than one y-intercept because we're dealing with functions. To calculate this, I need to go and I need to plug 0 in for x. So the y-intercept happens where x equals 0. So the value of the function at 0. I'm using my function, plugging in 0 for x. -4, quantity squared is 16, and 16 minus 1 is 15. So my y-intercept is at 0, 15. What about the x-intercepts? Well, the x-intercepts happen where y is equal to 0. So let's see. My y-intercept we calculated there. My x-intercepts happen where y is equal to 0. X-intercept occur where y is equal to 0. Y is the same thing as my f of x. So I'm going to replace f of x, my function notation, with 0. And I'm going to solve for x. All right, I need to move that 1 over first. Oh, you know what? No, I don't. Let's, instead of solving it like that, let's go ahead and FOIL this binomial. That's going to be the simplest approach. If I FOIL this binomial, I'm multiplying x minus 4 times x minus 4. I can come over to the side and step out the process, the steps of FOILing that, or I can use my shortcut. First term squared gives me x squared. Multiply the terms together times 2 to get my outside and inside products. So that would be -4x times 2 is -8x, and then -4 squared is a positive 16. And I still have that -1. That gives me x squared minus 8x plus 15, and that is factorable. So x equals, or excuse me, 0 equals, my factors are going to have the same sign. My middle term tells me they're both negative. What are factors of 15 that add to 8? Well, my factors of 15 are 1 times 15 or 3 times 5. 3 times 5 add to 8. Then I set each of those expressions equal to 0, and I get x-intercepts of 3, positive 3, and positive 5. All right, so my x-intercepts are at 3, 0, and 5, 0. Let's make sure that that all makes sense and fits on my graph. I've got a vertex at 4, -1. X-intercepts proposed at 3, 0, and 5, 0. Oh yeah, look at that. They're balanced around the vertex. And then I have a y-intercept at positive 15. My graph only goes up to 10, I believe, so 15 is going to be way up here. When I sketch this parabola, it's going to look like that, nice and balanced. Arrows in the ends because we just have a piece of it. It keeps going forever and ever. Domain and range. Well, quadratic functions have a domain of all real numbers all the time. That never changes. My range is limited by either my maximum or minimum. In this case, it's a minimum. So my range is from -1 inclusive to positive infinity. Okay, let's do another example together. This time, my function is presented not in my graphing form, my standard graphing form, but it's presented to me in general form. I've got the general form of my quadratic equation. So I've got ax squared plus bx plus c. So I have a value for a value for b, and a value for c. And I'm going to use those values to help me find the vertex. I can't look at it and find the vertex. What can I see when I look at it? Well, I see that my squared term is negative, which reflects it over the x-axis and means it faces downward. That means I have a maximum function value, but I don't know what it is yet. I can see my y-intercept, because if I plug in 0 for x into my function, I have 0, 0, and I'm left with -3. So my y-intercept is going to be at 0, -3. I also know the domain because it's a quadratic function, so my domain is always all real numbers. The other things I have to do some work to figure out. I don't just know the rest. To figure out the vertex, I start by finding the x-coordinate using -b/2a, that piece of my quadratic formula. Well, -b is the opposite of b, so that's a -8 over 2 times, and in this case, a is -4. That gives me -8 over -8, which is just 1. So the x-coordinate of my vertex is 1. That x-coordinate, that shift, also tells me what my axis of symmetry will be. It will be the equation x equals 1. What about the y-coordinate of my vertex? The y value is going to tell me what that maximum is. Let's take this 1 and plug it back into my function to get the y-coordinate of this graph, this vertex. So f of x becomes f of 1. That would be -4 times 1 squared plus 8 times 1 minus 3. Well, 1 squared is just 1. So I have -4 plus 8 minus 3. Well, -4 and -3 is a -7, plus 8 is a +1. So the y-coordinate on my vertex is also 1. So that means my maximum value is going to be 1. Let's start our graph. We have a vertex at 1, 1 right there. We know our y-intercept is at 0, -3. So that works because that makes my parabola turn upside down. What I need to know before I complete my graph, what are those x-coordinates for my x-intercepts? Well, to find my x-intercepts, I'm going to have to come down here and do a little bit of work. I find my x-intercepts by, they happen where y is equal to 0. The x-intercepts occur where y is equal to 0. So that means my function value is 0. And I have 0 equals -4x squared plus 8x minus 3. Now, I don't like to factor anything when I have a negative first term. So I'm going to move everything over to the left. That's going to change the sign. Oh, goodness. That's going to change the sign on all 3 terms. So my first term is positive. My second term is negative. And my last term, my third term, is positive. Now I can factor without having to worry about that negative out front. Now I have a couple of options here. 4x squared could factor to be 4x times x or 2x times 2x, and I don't know for sure which it is. My middle number isn't very large, so I'm going to guess that probably that first coefficient is going to split, and I'm going to try this first. If it doesn't work, I'll go back and try 4x times x. Let's try this first. Our last term is a +3, which means these signs have to be the same. Look at the center term. That tells me they're both negative. 3 is easy. 3 is 3 times 1. It's prime. So let's plug that in and check to see if this works. My outside product is a -2x. My inside product is a -6x. -2 plus -6 is -8x. So we're good. I set each of these factors equal to 0 to finish solving for my x-intercepts, also called the roots or zeros of my function. For this first one, I move the 3 over and then divide by 2. So I get x is equal to a positive 3/2. For the second one, I move the 1 over and divide by 2. I get x is equal to a positive 1/2. So my x-intercepts fall at 3/2, 0, and 1/2, 0. Let's see if that works on my graph. Oh, it's perfect. So 1/2 and 3/2 is 1.5. I can connect these dots into a nice balanced parabola. I see that I have my axis of symmetry at positive 1, just like I said. Now we need to fill in range. Range is limited by the maximum or minimum. In this case, we have a maximum value for the range, so that's the highest possible point. So my range is from -infinity up to and including 1. The remaining pages in this guided notes includes 6 more practice problems. We're going to do the odds. You are welcome to do the evens on your own and contact me if you want a key. Okay, so let's do number 1. This equation, this function is quadratic because it is a second-degree polynomial. It is in my graphing form, so that makes things easy. And I know that it's going to open upward because my x squared term is positive. So let's see what we know right off the bat. We know that my vertex is going to be at 3, -4. So I can stick that on the graph. 1, 2, 3, 1, 2, 3, 4. My vertex is going to be right there. I know my axis of symmetry is going to be the line, the vertical line that goes through that x coordinate of my vertex. So my axis of symmetry will be right there. I know that this function is going to have a minimum value because it's going to open upward. That x squared term is positive. I don't know what that value is yet. Since I'm in graphing form, I have to do work for the y-intercept and the x-intercept, but my domain of quadratic functions is always all real numbers. Okay, let's go in and do our work to see what else we need on our graph. The first thing next that we need says the minimum value. We're not going to know that. Oh, we do know that. I'm so sorry. We know that from our vertex because it's already done. We know that our minimum corresponds to the lowest y coordinate of our vertex. So that value is -4. Now we're going to get to work. Okay, y-intercept happens where x is 0. So my y-intercept happens where x is 0. So 0 minus 3, quantity squared minus 4. That -3 squared is 9, and 9 minus 4 is 5. So my y-intercept is at 0, 5. So 0, 1, 2, 3, 4, 5. That works. So I have my function facing upward. Now I just need to know what those x-intercepts are going to be, those roots or zeros of the function. X-intercepts happen where the function, the y, is equal to 0. So I have 0 equals x minus 3 quantity squared minus 4. I'm going to FOIL this either off to the side or using the shortcut. The shortcut tells me x squared multiply together times 2 is a -6x. Square that, -3 gives me +9, and then I have -4. So when I simplify, I have x squared minus 6x plus 5, and then I can factor that. So when I factor, I need factors of 5 that add to give me 6. Well, 5 is prime, so that's easy. I'm going to have x minus 1 and x minus 5. So when I set each of those equal to 0, I get a +1 and a +5 for my x-intercepts. So I have the points 1, 0, and 5, 0 for the values where my graph will cross the x-axis. At 1, 2, 3, 4, 5, notice how it's balanced around that axis of symmetry. And I can sketch my function, my parabola that represents my quadratic function. Okay, my range is based on that minimum value, the y-coordinate from the vertex. The lowest point on my function is -4, and it goes up to positive infinity. Like I said, we're just going to do the odds and leave the evens for you to do on your own. So let's move to number 3. This function is given to us in our general form, ax squared plus bx plus c. So we're going to have to do work to find the vertex. What I do know is if I plug in x, my y-intercept is 9. That's given. It's quadratic, so I know my domain is all real numbers. I know that right off the bat. But that's it. Oh, I know that because this is positive, it's going to open upward. So I have a minimum function value. I don't know what that is until I find my vertex. Well, how do we find our vertex in this case? We use x equals -b over 2a, where -b here is a -6. And then 2 times a is 2 times 1, because my coefficient on my squared term is just 1. So -6 over 2 is a -3. That's the x-coordinate of my vertex. That's also the value for my axis of symmetry. So that axis of symmetry is going to be the equation x equals -3. My graph is going to be over here, 1, 2, 3, where x is equal to -3. There's my axis of symmetry. And then to find the y-coordinate of my vertex, I take this -3 and I plug it into my function. So I have -3 quantity squared plus 6 times -3 plus 9. Well, -3 squared is 9 plus 6 times -3, let's make that a -18, and then plus 9. Well, 9 plus 9 is 18 minus 18. Those add to 0. So the vertex is at -3, 0. Oh, look at that. This x-intercept right here, that is my vertex. So the minimum value of my function is 0, right there. The y-intercept is at 0, 9. That's going to be up here. Now, we already know that my vertex of my function sits on the x-axis. Is my graph going to intercept the x-axis anywhere else? No, it's not. My only x-intercept is that -3, 0, the vertex of my function. If I sketch this graph, I can get another point over here because I see that I've moved 1, 2, 3 units to the right of the axis of symmetry. So I can go 1, 2, 3 units to the left, and that is a nice balanced parabola. And the range of this function is limited by the y-coordinate of the vertex. The range is from 0 to positive infinity. One more example together. We have done, let's think about this. We just did a graph where we had 2 x-intercepts. We've done a graph now where we have 1 x-intercept. Let's look at a graph where we have 0 x-intercepts and see how that happens. Okay, again, I'm in that general form. I don't know where my vertex is right away. I see that I have a quadratic function, so I know my domain is all real numbers. I see that my squared term is positive, so I know it opens upwards, which means I have a minimum value. And I can figure out my y-intercept pretty simply, because if I plug in 0 for x, those two terms are 0, and my y-intercept is 3. So I've got this point 1, 2, 3 right there. That's all I know so far. Now I do a little bit of work. I find my vertex by using x equals -b over 2a. In this case, -b is a positive 2. Over 2 times 1, because my coefficient of the squared term is 1 again. Well, 2 times 2 is just 1. So my vertex is at 1. That x-coordinate of my vertex gives me the equation for my axis of symmetry. So I'm going to go ahead and put that on the graph. My vertex, I move over to 1. My axis of symmetry is going to be there, right? I don't know if where my vertex is up or down, however, so let's figure that out. By taking that 1 and plugging it into the function. So 1 squared minus 2 times 1 plus 3. 1 minus 2 plus 3 gives us a simplified value of 2. So my vertex is at 1 over 1 up 2. That makes sense. That's going to go up like that. The value of my minimum is 2. That's what I just found here. That's the lowest point. X-intercepts. All right, guys, look at this. If my vertex is here, my y-intercept is there, that means I'm going to have another point over here that matches. My parabola opens upward. Does my graph intercept the x-axis? No, it does not. I'm going to say NA for not applicable. There are no real number x-intercepts. I'm going to show you arithmetically why that is as soon as we finish this range. My range starts at 2 and goes to positive infinity. Now, arithmetically, why do we not have any x-intercepts? Well, my x-intercepts, I can tell that from the graph, so I didn't have to do any calculations. But x-intercepts happen where y is 0. So if I take my function and replace f of x with 0, I get x squared minus 2x plus 3. Well, this tells me that if I were to factor this, my factors would both have to be negative, and I've got 3 and 1. Negative 3 and negative 1 is not going to add to 2. It's going to add to negative 4. So it's not factorable. That means I have to use my quadratic formula. I would have negative b, which would be positive 2, plus or minus square root of b squared minus 4 times a times c all over 2a. Let's look at the discriminant, the value underneath the radical. That value underneath the radical comes out to be 4 minus 12, which is a negative 8. A negative radicand underneath my square root tells me that I have imaginary values. Well, imaginary values do not show up on my real number graph. I could stop here as long as I'm not asked to give these imaginary roots. If I'm asked to give them, let's see what that looks like when I simplify. I would have 2 plus or minus the square root of negative 8 over 2. Well, 8 is not a perfect square. We know that's going to be imaginary. It's not a perfect square, but I can simplify. 2 plus or minus square root of negative 1 times 2 times 4 is what gives me negative 8. When I simplify that, square root of 4 is 2, square root of negative 1 is I. So I bring out that 2i. I have to leave the square root of 2 behind. It won't simplify at all. And notice I simplified my radical to 2i square roots of 2. I split my numerator into 2 separate terms. So 2 over 2 plus or minus this radical over 2. 2 over 2 is 1 plus or minus. Now 2 over 2 simplifies. So I have I square root 2. That's my two imaginary roots. 1 plus I square root 2 and 1 minus I square root 2.